All right, today we're going to be adding some more vocabulary terms to our Unit 4 list, and we are then going to see how we can apply those terms in order to help us analyze more relations and functions. So, the first new vocabulary word should sound very familiar from your science class, and that is independent. And independent is just a variable that does not depend on another variable. It can also be referred to as the input value. And we are adding a new word for math class. It can also be referred to as the domain. So think of your independent variables as your x. All right. Then we have dependent. And dependent is just a variable who depends on another variable. This can also be known as the output value. And our new vocab word for algebra is going to be, it's the range. So think of that as your y value. So we are going to read this statement and we are going to see which one is stated correctly. So let's go ahead and look at that. Circle the statement below that is correct. How far I can drive depends on the amount of fuel that's left in my tank. The amount of fuel left in my tank depends on how far I can drive. Well, I might want to drive 100 miles, but if I don't have enough fuel in my tank, I cannot drive that far. So how far I can drive is dependent on how much fuel is in my tank. So in this scenario, the independent variable is the amount of fuel in the tank. And the dependent variable is how far I can drive. And again, your independents are going to go on your x-axis when you graph them, and your dependents are going to go on your y-axis when you graph them. So let's look at a couple of scenarios and just kind of sketch out what we think would happen. So student council is going to be selling homecoming t-shirts for $5 each. Sorry, for money, and they get a $5 profit for every shirt they sell. That is very different than selling them for $5. So the independent variable is the number of shirts sold. So we're going to label the x-axis shirts sold. And the dependent variable would be that profit. So we will label the y-axis profit. So as I think through how would this look, I can only sell an entire t-shirt. So this is going to be discrete. And the more I sell, the more my profit goes up. So that's kind of what that sketch would look like. Okay, next one. Bob has a swimming pool. It is now fall, so he needs to empty it. He empties his swimming pool at a rate of 10 gallons per minute. Okay, so the independent is the amount of time. And the dependent would be the amount of water in the pool. And let's kind of visualize this. So if I haven't started emptying the pool, I got a lot of water in my pool. As time goes on, that pool water is going down until eventually I have emptied the entire pool. And during that, water and time are going to continually decrease. Like it doesn't have to come out in whole gallon amounts. It can come out parts at a time. So that would be an example of a continuous scenario. Okay. So now let's jump in and let's start looking at actual graphs and being able to identify and answer questions based off of the graphs we see. So again, domain is going to be the set of x values, and range is the set of y values. If it's discrete, or if we're given just a distinct set of points in a table or ordered pairs, then our domain and range are just going to be a list of values. If it's a graph that is continuous, then our domain and range are going to be compound inequalities or inequalities so that we don't have to list every single possible point. So example 4, the domain, remember, is your x values. So we're just going to come through and write down the list of values. I will always go least to greatest. So -5, -2, 0, 3, and 6. If a number were to repeat, you do not have to write it more than once. My range, and again, I'm just going to go least to greatest, -23, -14, -8, 1, and 10. All right, again, domain is your x values, so I'm going to list those. -4, -1, 0, 2, and 7. My range are my y values. F of x is just a fancy way of describing the function of x, which is really just saying what is the output for this x value. So that is a fancy way of saying the range. So over here, I'm going to go -5, 0, 1, 2, and 4. Okay, for this next problem, I am going to look for the x values of the ordered pair. So I have an x value over here at -3. The next point, I have an x value at -2. The next point, my x value is 0. And the next point, my x value is 3. So I just moved left to right from my points, listing out the x values. Now, for range, I'm going to start my lowest point, which is down here. That has a y value of -4. The next lowest point is right there with a y value of 0. Then I've got a point up here with a y value of 2. And a point up here with a y value of 4. All right, now I've moved into continuous. So now I don't have to list every single point because there's all those points with fractions and decimals in the middle. That would take way too long. So when it's continuous, I am simply going to go, okay, what is my farthest to the left point? What is my farthest to the right point? So this graph is going from -2 to +7. And because both of those points were closed circles, I'm going to use the less than or equal to. All right, same thing now for range. I'm going to go to my lowest point on the graph. I'm going to go to my highest point on the graph. And I'm going to say, okay, this is going from -3. Those were both closed points. So less than or equal to, and the highest point was at 6. All right, domain. Right there, I have a closed dot at 0, and this arrow implies it just keeps going. So the domain on this one is going to be x is greater than or equal to 0. And then for range, my lowest point is at 0, and that arrow also means it just keeps growing and growing and growing. So my range is going to be y is greater than or equal to 0. Now, last point says, okay, I want you to look at this function, and I want you to tell me when my input is 4. So that f of x is saying when the input is 4. So come find the input of 4. Look up, hit the graph, look over. I have an output of 2. So for this function with an input of 2, it will equal an output, or input of 4, it'll equal an output of 2. That's how we read it. F of 4 equals 2. Okay, let's look at the next one. So this arrow and this arrow implies that this graph just keeps getting wider and wider and wider, so the domain is all real numbers. This graph does, though, have a lowest point. So I'm going to say range is y is greater than or equal to -3, because the arrows also imply it just keeps getting taller and taller. Okay, now they flipped it on me. They said my output value is 1. So I'm going to come to an output value of 1, and I'm going to look and say, okay, when did that happen? And I'm going to look down and go, ooh, it happened at -2, and it happened at +2. So I'm saying for f of -2, out will come a 1, but also for f of 2, out will come a 1. All right, this first graph, we are just worried about the range. Okay, so on the first graph, before, the range is y is greater than or equal to 0. So this is from a Desmos graphing calculator. It doesn't use arrows because on Desmos you can literally just keep growing and growing and growing, so the line just continues forever. But it is implying arrows on this. Now, over here, I have said, okay, start it at 1, stop it at 5. So I restricted the domain. And I am asking, what does that do to the range? So now let's look. After, now my range still has a low point at 0. And that was a closed circle. Y is less than or equal to. But now it doesn't keep going. It has a high point at 3. So by restricting or cutting off the domain, saying start here, stop here, that's what a restriction is, it also will affect the range. And now I have a starting and a stopping point on my range. Whereas before, when I just let it do its own thing, I had a starting point for the range, but I'd never had a stopping point. Okay, hopefully that kind of helps that idea of domain and range restrictions. We are really going to be using that a lot. I know several of you have looked at the back wall in my room and seen all the magnets with the projects. Those projects are created by placing domain and range restrictions on functions and relations. So that's what we're going to be practicing and working towards. This is just laying that foundation, that groundwork. Okay, so now what does this look like in like a word problem? So let's jump in. On Black Friday, the local electronics store is selling copies of Call of Duty World War II for $45 each. But the store only has 100 copies of the video game in stock. Okay, so thinking about this, the independent variable here would be the number of games sold. And the dependent variable here would be the money made. Now, this is going to be a discrete scenario because you cannot sell 2.3 video games, okay? So it's going to be discrete, and then that's going to help me with how I'm going to write my domain. So my domain is going to go in set notation. I can sell 0 video games. I can sell 1. I can sell 2. And then I'm going to put ... And then I'm going to say, okay, but the maximum I can sell is 100. And that way we can see what the pattern is, but I don't have to sit here and list the numbers 1 to 100. Okay. The range on this word problem, again, starting at 0, and every time I sell a video game, it was $45. So 1 sold is 45, 2 sold is 90, and then again, I'm going to go ... And if I were to sell all 100, I would have made $4,500. So there's my range. And sorry, I should have done that in blue. I've been color coding everything. And then I got silly thinking about money and went to green. But we're doing range, so blue. Okay, let's look at the last one. Ben earns $8.50 per hour at his part-time job. His parents are worried about his grades, so he has been allowed to only work a maximum of 10 hours per week. So that's what his parents have told him. Okay, so The independent is the hours worked, and the dependent is going to be the money earned. Now, this scenario is actually going to be continuous. If you're an hourly employee, when you clock in and when you clock out, you are paid for all that time. So if you work for 2 hours and 10 minutes, you're going to get 2 hours and 10 minutes worth of pay. It doesn't have to be exactly whole hours. So now typically they have you work an hour or an hour and a half shift. But if you ended up working over, you would get paid for that amount. So in this scenario, my domain is going to be a compound inequality starting at 0 and then going up to the parent's restriction of 10 hours. So 0 less than or equal to x less than or equal to 10. And then the range is based on what we get paid. So work 0 hours, get paid $0. There's real life. Less than or equal to y, less than or equal to. But if you're making $8.50 an hour and you work 10 hours, technically you've made $85 before taxes, but we're not going to worry about taxes on this word problem. All right, and that is the end of looking at independent and dependent variables and using a new vocabulary term, domain, to describe input or independence. Range describes output or dependent variables. And then again, we're bringing in that continuous discrete idea from our first lesson. That's the end of today's topic.